In this video, I will show you how to create an Amazon EKS cluster using EKSCTL, install ArgoCD on the cluster, access the ArgoCD dashboard, and log in. The prerequisites for setting up this is you must have AWS CLI installed on your laptop. You must have access keys and secret keys generated using AWS command line utility. So I have access key and secret key generated for my local laptop. You must have EKSCTL installed. EKSCTL is specially designed for managing Kubernetes cluster on Amazon. It's a command line utility which simplifies the setup of EKS cluster. In the background, it uses CloudFormation templates to provision the cluster. The command to create EKS cluster using EKSCTL is EKSCTL create cluster, provide name of the cluster, version, region, node group, nothing but group of EC2 instances where our workloads get deployed, node type, number of nodes, minimum nodes, maximum nodes. Minimum and maximum takes care of configuring auto scaling. Initially, it will set up 2 nodes. When the load is increasing, it can go up to 3 nodes. Let's execute this command. It takes up to 10 minutes to set up the cluster. I will pause the video and come back once it is ready. Cluster creation completed. Let's check the status using kubectl command. There are 2 nodes running. They are in ready state. After EKSCTL create cluster command finishes, it also generates access to EKS cluster in the background. Those details are kept by default inside .kube folder, which is a hidden folder. And if you see config file, it will have the access details for the Kubernetes cluster. Now we should install ArgoCD inside EKS cluster. I'm creating a separate namespace for ArgoCD. Inside this namespace, let's install ArgoCD. ArgoCD is GitOps continuous delivery tool for Kubernetes that automatically syncs Kubernetes resources from Git repository onto Kubernetes cluster. Let's see ArgoCD installation status. I'm running kubectl get pods inside ArgoCD namespace. All are in running state. This concludes ArgoCD is successfully running. Now we want to access ArgoCD web interface, but by default the service created for ArgoCD is cluster IP. I want to change cluster IP to load balancer so that we can use this load balancer endpoint to access from the web browser. Let's use kubectl get svc under ArgoCD namespace. ArgoCD server. This is the one we need to update. Right now its type is cluster IP, meaning it can be accessed only within the cluster. But I want to access this from my laptop. Let's edit this, change cluster IP to load balancer. kubectl edit service name namespace ArgoCD. Remove cluster IP and make it load balancer. Save and close. Now it creates application load balancer in the background. This takes few seconds. After that, we can access ArgoCD from the web browser. Let's run a kubectl get svc command. We should find load balancer endpoint, copy that, put it in the browser. The load balancer provisioning is still happening. Let's wait for some time. Yeah, the application is ready. I refresh the page, click on advanced, click proceed to. We should see ArgoCD web application now. Its default username is admin. I want to get the password, initial admin password. I'm going to use a command to get this initial admin password. I will put all these commands in the resources section. You can download and use it. Put the password and sign in. Let's walk through the code and manually deploy it from the local command prompt, so you clearly understand each and every step. In the next video, we take this process further and automate it using GitHub Actions workflows. We already have a Flask Python application. When we send a request to the root URL, we get a message, "Hello from Flask on Kubernetes." Since this application is built with Flask, this dependency is added to requirements.txt. This application by default listens on 8000 port. If you want to change it, at runtime you can pass port environment variable by giving your own port number. Let's take a look at Dockerfile. We start with Python lightweight base image. We are creating work directory. This will create /app folder on Docker image if this folder doesn't exist already. We are copying requirements.txt. We are installing dependencies from requirements.txt. It has one dependency, that is Flask. We are telling this application listens on 8000. We are copying entire code onto Docker image, and we are running this application using Python main.py. Let's manually build this image and push it to Docker Hub. Open terminal. Use this command, docker build -t, and before building and pushing Docker image to Docker Hub, you must log in. On my machine, I'm already logged in. For your reference, the command is docker login -u username -p password. This is the syntax. If someone is watching your screen and you don't want that guy to know your password, then better try this command, docker login -u username. It will prompt for a password, so the password is not displayed. Login successful. Let's build Docker image, push it to Docker Hub. In order to push this image to Docker Hub, you must tag it accordingly. Prefix must be Docker Hub username, that is Kamana, / image name I am giving PyApp. Let's make this v1 as a version. Use dot. This is the current context Docker uses to build this image. Hit enter. Alright, Docker is not running on my machine, so we are not able to connect to Docker daemon. I'm opening Docker desktop. Docker desktop is running, so Docker daemon is active. Run docker build command again. it builds Docker image. Let's push this Docker image to Docker Hub. Docker push followed by command/pyapp:\v1. Docker image is pushed successfully. Copy Docker image details. To deploy this onto Kubernetes cluster, we need deployment file and service file. I have written these files already. Let's take a look at deployment file. This is a typical Kubernetes deployment specification file. I'm giving kind, name, labels, replicas, match labels, so on and so forth. Change image and provide image details, the one we just pushed to Docker Hub. Container port, it listens on 8000. When we send this to Kubernetes Cluster API, it deploys 3 copies of PyApp application. After this is deployed, we want to access from the browser and see its response. I have created service file as well. Kind is service, name, labels. Make sure these labels are matching with, so this one here, the pod specification labels. I'm making this type load balancer. Target port is 8000, meaning when I send request to load balancer, it routes traffic to the pods that are listening on 8000. Let's open command prompt and deploy Kubernetes manifest files to the cluster. cd into Kubernetes folder K8s. Let me also check how many nodes are running currently. There should be 2 nodes running and they are in ready state. Use kubectl, apply command, provide path of the folder that contains service and deployment YAML files. We are already inside K8s folder. I'm saying /, meaning everything in current folder. It created deployment and service both. Let's get the status. Let's do get pods. 3 pods are running. I'm sorry, they're not running, they're getting into crash loop back off. Let's have a look why it is getting into crash loop back off. Use describe command on the pod. It's able to successfully pull the image, but looks like something wrong with the application itself. Let's see the logs of the pods. We got an error, exec format error. This is happening because we built Docker image on Mac ARM architecture and we are running it on EKS cluster. So this architecture is mismatching. Let's use docker buildx command and specify the platform for which we want to build this Docker image. I'm running it in a wrong folder, cd one directory backwards. Run this command. Let's push this image. Let's delete the existing deployment in Kubernetes. And let's create this again. cd into EKS cluster folder, that is K8s, kubectl apply -f current folder. Service is already deployed, that is unchanged. It's creating just deployment. So maybe we again built a new Docker image with same tag v1, and the old images are cached on these nodes. It's using the cached images and causing same problem. Let's build Docker image with tag v2. Let's come back to root folder where Docker file is present. Build it. Push it with v2. Change it in deployment file. v2. cd into K8s folder. Now it has to use version v2. These pods are successfully running now. Let's get service details. Grab load balancer URL. Put it in the browser. We're getting a message, hello from Flask on Kubernetes. In next video, let's automate this complete process using GitHub Actions workflows. Let's start the automation of Python application deployment onto Kubernetes cluster. First, let's begin with CI automation using GitHub Actions workflow. Let's commit these changes into Git repository. Let's do git init. Let's stage changes. This is my mistake. I should do git init outside of Kubernetes folder, that is K8s folder. Let me remove .git hidden folder, come one directory backwards. This is our project root. Let's initialize Git repository inside project root. Let's create a repository in GitHub. I'm naming this GitHub Actions EKS. Create repository. Copy this command so we can map local repository with remote repository. So run git remote add command. So it maps local repository with the remote one. Let's push changes to remote. Refresh the page. We got changes. Let's write GitHub Actions for this application, a CI part. Let me pick the random option because I'm going to write everything from scratch. Let's name this workflow Kubernetes CI. I want to trigger this when there is a push on main branch. Jobs, PyApp CI. That's the name of the job I'm giving. Let's configure the runner Ubuntu latest. Let's add steps. I'm using checkout action to check out the code from this repository. Let's build Docker image. Docker build. I want to push this image to Docker Hub. So I need to prefix it with my Docker Hub ID, that is Kamana. Let's give a name, GitHub Actions, PyApp, and the tag I want to provide here. I don't want to hard code this. I want to generate tag dynamically. Let's choose one approach for this. I want to pick the latest commit ID as a tag. When there is a change in code, it gets new commit ID, doc image gets new tag. Let's put double quotes. So in place of v1, I want to use built-in variable $GitHub underscore SHA. Let me commit and test our code if it is working fine, and we will move on with next steps. Commit. Go to actions. Workflow got triggered. Open it. Yeah, it's doing Docker build. Yeah, so it's getting the latest commit ID. We are using that as a tag. I don't want this lengthy SHA. I want just 7 characters. That should be enough for us. Let's make changes accordingly in workflow file. So in this, yeah, I'm grabbing only 7 characters, using that for my tagging purpose. We need to log into Docker Hub. Only then we can push this image. There is an action for that, docker/login action. It takes inputs, that is username. I need to read username from GitHub secrets. Let's open settings in a separate tab. Secrets and variables. click Actions. I want to add repository secrets. Let me put Docker Hub password. For this, I need to generate a token from Docker Hub portal. Let's log into it. Let's go to settings. Let me check under my name. Yeah, account settings. Personal access tokens. Let's generate a new token. Let me keep this expiration 30 days. I want read and write both. Generate. Copy this token. Set it here. I want to add one more for username. This is my username. Add the secret. We want to use these two secrets in GitHub Actions workflow. The syntax is secrets dot secrets name. Password. Docker underscore password. Let's test this. Go to Actions. Workflow got triggered. I want to make sure authentication is working. Authentication is failing. We need to fix this. Let me test this from my local to make sure I'm not doing any mistake. Let me copy the personal access token. I'm pasting it. Yeah, it's working fine with me. Let's check our workflow file if you're doing any mistake. Go to workflow file. Edit this. So Docker login action. Username and password. Docker Hub username and Docker Hub token. I'm updating the username to make sure I did not do any typo issues. update it. So come back. Let's make it. I want to rerun all the jobs and see if it is still failing. Let's go back to workflow file. Okay, I think this must be double curly brace. Commit. Go to actions. Wait for this workflow to finish. Yeah, so login is working fine. So let's push Docker image to Docker Hub. Open workflow file, edit, so after this, I want to update deployment YAML file with latest tag. I want to use a tool for updating a YAML file, that is YQ. I'm copy pasting that code. Install YQ. I'm downloading that binary and adding that to the path, giving proper permissions. So we can use YQ and easily update deployment YAML file. Run. Let's use multi-line script here. Yeah. So I'm getting the short SHA, which we used earlier step. I'm using YQ command. I'm telling to update a specific entry inside YAML file. Let's open a YAML file and I'll show that YAML file structure. K8s, this one, deployment.yml. I want to update this specific one. .spec .template. So dot means the entire document root. Spec .template dot containers. This one, this is a list. We can have multiple containers, but we have only one. In that first container and that particular image. So this one we are updating. But we are building Docker image with a different name, right? So GitHub Actions Py app is the name. So I'm making sure the image name here is GitHub Actions -Py app. And location of the deployment file. So it is ./k8s. Inside ./k8s, this is the file name. Okay. And one more change we must do. We need to update this. The image name is not correct in the YAML file. Let's update that. Now it's going to change only this particular one. Yeah. So let me commit this. And we also should commit workflow changes. So commit and do the commit. So go to actions. It triggered two because we made two commits. One is for deployment YAML where I fixed the image name, and second one is I updated workflow file. Let's see what updates it's doing here. Okay, so but overall workflow is successful. The updated file I want to commit. Go to workflow file, edit. Because we updated deployment YAML, that has to be committed to Git. Because in next step what we do is we configure ArgoCD which is pointed to this repository. When ArgoCD finds those committed changes, it picks those changes and applies those changes onto Kubernetes cluster. So after this, name commit deployment file changes. Let's use run and multi-command script. So we need to configure username and also email. Git add k8s this file, git commit, Docker tag updated by GitHub Actions, commit changes, and let's test the workflow file. Workflow finished successfully. Let's see the deployment file if it is properly updated. No, this is not getting updated. Let's see if there is any mistake. Okay, I'm not pushing it. That's my mistake. Git push origin main. Go to actions. Yeah, open this. Wait for this job to finish and make sure it is successfully updating Kubernetes deployment file. Okay. Permission denied. We're unable to perform git commit and push. Let's see if there is any workflow permissions. Go to settings, actions, general, workflow permissions. Okay. So by default, workflow has permissions to read. I want read and write permissions in this case. Save it. Open workflow trigger. Open the job. And let's wait for this job to finish. Finally, it worked. Okay. Let's see if changes are updated. Oh, okay. So we need the value, right? We don't need a dollar short SHA. So let's fix this one also. Workflow file, edit. So we need to escape this string because right otherwise this is directly getting onto deployment YAML. I don't want this directly. I want its value. Let's do commit. I don't see any syntax issue. Job is successful. Let's refresh the page. Yeah, it is properly updated now. So let's move on to next video and prepare for CD. In previous video, we have seen how to build Docker image and update Docker image tag in deployment YAML file. Now, we want to deploy this onto Kubernetes using ArgoCD. ArgoCD is GitOps tool, meaning we can keep the state of the application in Git that is used by ArgoCD to deploy applications onto Kubernetes cluster. In our case, after building Docker image, we are updating deployment YAML file. So whatever changes we put in deployment YAML file on Git, those changes will be synced with Kubernetes cluster. Let's go and create new app. Let's give it a name. I'm calling this GitHub Actions Demo. Project name, choose default, sync policy. Kubernetes has two options, manual sync and automatic sync. In case of automatic sync, Whenever there's a change happening in a Git repository, those changes are automatically deployed onto Kubernetes cluster. Usually manual sync happens in 3 minutes duration. Let's go with automatic sync and come down. We need to select the repository URL. Our repository is GitHub Actions EKS. Copy this. Select the revision. I want to use main branch for deploying and choose the path. In the same repository, we have application code as well as Kubernetes deployment files. And what I want to do in this case, I want to give K8S as a folder, meaning ArgoCD is going to check only K8S folder in the given repository. Only when there are changes inside K8S folder, only then it performs automatic sync in this case. Come down where it has to deploy. Of course, it should deploy onto Kubernetes cluster itself. Keep in mind, Argo CD is also running inside Kubernetes cluster. The cluster URL is this one. Select that namespace. On which namespace we want to deploy these changes. Let me put default namespace. So remaining options I'm leaving as it is. Create. Now, Argo CD uses the repository we gave. It picks files inside K8S folder and deploys them. If you go to K8S folder, we have two files. One is service, other one is deployment. We are saying 3 replicas, correct? Let's open this application. It has to deploy 3 replicas. Let's check that using kubectl getpods command. 3 replicas are running. Let's get service. There is a load balancer service deployed. Copy the load balancer URL. Go on to browser. Hit this. It might take few seconds to come up. It is deployed. Suppose we want to change number of replicas from 3 to 4. What we do is we make those changes directly inside deployment file. Let me edit, change 3 to 4, commit. It's populating automated commit message. Done. This triggers GitHub Actions. It's going to build a fresh Docker image, push that image to Docker Hub, update Docker image tag inside deployment YAML file. That is going to trigger Argo CD deployment. This is successful. And if you see, K8 folder is updated just now. This triggers Argo CD deployment. Usually, every 3 minutes, it goes to Git and checks for changes. We should either wait for up to 3 minutes or click on sync, which takes care of syncing right away. In real world, we don't need to really click the sync button. It's going to happen automatically. Let's run kubectl get pods. There should be 4 replicas. Now, let's change the color, which is going to trigger GitHub Actions workflow and Argo CD for automated deployments. Let's test it. Go to main.py. edit this file. Right now, the text is coming in black. Let's change the text color to red. Commit. Check actions. There's a workflow which is triggered. Workflow is going to build a fresh Docker image, and it's going to update the Docker latest tag inside deployment YAML. That in turn triggers ArgoCD application deployment. Let's wait for a few minutes and come back and see if deployment is done. The sync operation is performed. Let's refresh the page. Looks like I made a syntax issue. Yeah, style should be color, and I want red as the color. Commit this. Now the entire process, building Docker image, deploying onto Kubernetes, is completely automated. Yeah. So workflow is successful. Let's go on to ArgoCD application. Either we should wait for 3 minutes because ArgoCD goes to Git every 3 minutes, checks for changes. I don't want to wait, so let me click on sync. Let's run kubectl get pods. Yeah, there are newly created pods with latest application changes. Let's go here, do refresh, and perfect. It is successfully deployed.